Skim motors and slip. This can be a bit of a tricky concept to wrap our minds around, so let's take a look at a basic skim motor and let's remove the rotor. Now, slip speed has to do with the rotating magnetic field that the stator windings will set up. So when we energize a stator field with three-phase, a rotating mass occurs of magnetic flux in one direction. Now, the speed of rotation is important. It's calculated by taking 120, multiplying it by the frequency, and dividing it by the number of poles in the machine. This speed that the stator field is rotating at is referred to as the synchronous speed, or n-sync. It's important to understand this because when we start the motor, we can see that there is a difference between the synchronous speed, which should never change, and the rotor speed. So if we were to start this motor and have no mechanical load connected to the shaft, it would mean that the motor isn't going to try very hard to turn the rotor. And as a result of that, it will take almost no time for the rotor to pick up speed. And it will come to almost the same speed as the synchronous stator speed. So what we'll notice is that the rotor should start almost instantly. The rotor will turn just slightly slower than the synchronous speed, and we say that this has then a very low percent slip. Remember, synchronous speed is based on how the machine is constructed and the frequency of the source three-phase. The rotor speed is determined by simply taking our n-sync minus our rotor to give us our slip. So in this case, perhaps we had a synchronous speed of 1800. Our rotor is turning at 1795, which means the difference of speed between the two, or the slip, is only 5 RPM. Now, this is in stark contrast to a motor started at full voltage and full mechanical load on the shaft of the motor. In this situation, we should see that it takes a substantial amount of time compared to the first example to reach its full rotating speed. So there, the synchronous speed is started, and we can see the rotor take some time to get up to speed, and also the rotor is not going to turn as fast. It's noticeably slower than the synchronous speed, and although it's still a low percent slip, it's 3 to 5%. So again, the synchronous speed has not changed. The rotor speed is slower now, and again, the synchronous minus the rotor will equal the speed of slip. And again, if we took 1800 RPM, 1710 rotor speed would be appropriate for full load, and that would then mean that we've risen to a 90 RPM difference of speed between the two, or the slip speed.